let's get started on building our budget app. In this series of modules, we're gonna have several goals that we will be working towards. First, we will cover the concepts of Riverpod, hooks, consumer widget, and hook consumer widget. Next, we will delve into the model view model architecture and understand its role in app development. As we begin coding, we will start with the login UI and we will implement email and Google authentication. From there, we will move on to the expense page UI and we will want to integrate the Firestore database. At this point, we will have implemented partial MVVM, but we will not yet be using models. Afterwards, our focus will shift towards improving the application's performance by reusing code and implementing more efficient practices, which will also help to make the code cleaner. Finally, we will introduce models and refactor the code to fully integrate them into the rest of the app. By completing the integration of models, we will have fully implemented the MVVM architecture in our budget app. If you need help visualizing the design of the app, you can check out the design at flutterbudgetapp.codingliquids.com. Additionally, if you get lost while working through the code, you can refer to the final budget app in the link provided before to understand the overall design and what we are trying to achieve. You can download the initial project from the resources section, and this is what we have here. There are already some pre-written codes in partial MVVM pattern, and we're using hooks plus Riverpod for state management here. Let me now explain the MVVM design pattern and why we're applying it in our code. So, MVVM is a design pattern that separates the presentation layer of an application, that is the UI, from the business logic, that is all other logic. It stands for model view model, where the model represents the data or business logic. The view represents the UI, and the view model acts as a mediator between the model and the view. The view model in MVVM is responsible for exposing the data to the view and handling UI-related logic. It ideally does not contain any UI code and does not know about the view. This separation of concerns allows for a cleaner, more maintainable code base and makes it easier to unit test the application. So, one of the benefits of using MVVM in Google Flutter is that it helps to keep the UI and business logic separate, which can make the code easier to understand and maintain. Flutter's reactive programming model, which allows widgets to be rebuilt automatically when their underlying data changes, is also a good fit for the MVVM pattern. Additionally, the use of MVVM in Flutter can make it easier to follow the single responsibility principle, which states that a class should have only one reason to change. With MVVM, the ViewModel class is responsible for handling the UI logic and exposing data to the view, while the model class is responsible for the business logic. Separating the concerns of the different components can make it easier to modify and maintain the code base over time, as I said earlier. Overall, the MVVM design pattern is a useful tool for organizing and structuring an application's code base, and it can be particularly helpful in the context of Flutter development practices and make testing and debugging more straightforward. The next thing that comes to our mind is Riverpod. Let me explain Riverpod in more detail, as some of you asked to explain the theory a bit more. So, Flutter Riverpod is basically a state management library for Flutter that allows us to store and manage our app's state in a simple and reliable way. It is built on top of the provider package, which is a popular solution for managing state in Flutter. With Riverpod, we can define our app's state as a set of providers that hold the data we need to display and interact with in our app. Providers can be used to store any kind of data, including complex object graphs, and they can be accessed and updated from anywhere in our app. One of the key benefits of using Riverpod is that it makes it easy to manage the lifecycle of the app's state. Providers are automatically disposed of when they are no longer needed, which helps to prevent memory leaks and improve the overall performance of our app. In addition to its core state management capabilities, Riverpod also includes a number of advanced features that can help us to write more reliable and maintainable Flutter code. For example, we can use the family feature to create groups of related providers, or the consumer feature to make it easier to access and update our app's state from multiple places in our code. Overall, Flutter Riverpod is a powerful and flexible tool for managing state in Flutter apps, and it is well worth considering if you are building a Flutter app that needs to manage a large or complex set of data. The next part I'm gonna explain is the Hook Consumer Widget class. And later in this video, I will explain why exactly we need it. We will be using it instead of stateless and stateful widgets classes. We can start by breaking the Hook Consumer Widget into two classes. One would be Hook Widget, and the other one, Consumer Widget. According to the Flutter docs, a hook widget is a widget that can use a hook. Its usage is very similar to the usage of a stateless widget. Hook widget does not have any lifecycle and only implements the build method. Now, on the other hand, a consumer widget is a stateless widget that can listen to providers. Using consumer widget allows the widget tree to listen to changes on the provider so that the UI automatically updates when needed. In short, the Hook Consumer Widget is basically a combination of both Hook and Consumer widgets. Allow me to explain it in a slightly different way. Hook widget is a widget in Flutter that allows developers to use hooks, which are a way to use state and other features of the Flutter framework in functional widgets. So, hooks are a way to manage state and other features of the framework without having to use classes and inherit from the stateful widget or stateless widget classes. Before I do anything else, let me show you how you can change the name of your Flutter application in Android and iOS. To do that, I'll head over to pubdev and I'll use this package called Flutter Launcher Name to change the name of our Flutter app. Now you're going to go over this first step, set up the configuration file, and copy the dev dependencies given in this gray box. And then open the pubspec YAML file and paste the copied content just under the SDK Flutter in the dev dependencies section. Now let's go back to the pubdev and copy the Flutter launcher name part, and we will paste it here. Make sure to check for the spaces. So in the name property, we need to write the name of the application we're going to create. I'm gonna write budget up here. It is as simple as that. The next thing will be to run this package. So in order to do it, we need to run these two commands given under the run the package. Simply copy these lines, go to your Android Studio, and paste them into the terminal. It is going to take a few seconds to run. First, it's running pubget, and then next command will automatically appear after the first one's completed. Let's hit enter to run the next command. Now you'll see these two words, start and exit. This means that it has successfully changed the name of the application we're working on. Amazing! Now I'm gonna move to the next part. The first thing will be to create a Firebase project. In order to do that, let's go and open the Firebase console. Now that the page has opened, let's click on Add Project and then name it Budget Up. Check the terms and conditions and click on Continue. Click on Continue again and then select your default account and click on Create Project. It's gonna take a few seconds, so be patient. And voila! You have created your project on Firebase. Our next task will be to add the apps. I'm gonna start with Android, So let's click on the Android icon. Here we register the app. Let's go to the Android manifest folder then and copy this line and paste it in the Android package name field. You can add your app's nickname. Keep the SHA as it is because we will come back to edit this later in this tutorial, and proceed further by clicking on the Register App button. Now, download the JSON file. This is an important step, so make sure that you place your file in the Android app folder. Getting the path right for the JSON file is very important. Otherwise, Firebase won't work on your app. I have already added the Firebase SDK, so you don't have to worry about it too much. And you can just click on Next. And then on this button, that will take you to the main Firebase console. Now that we are done with the registration part, our next task will be to add the SHA files. To do it, click on the Android button and then on Settings and scroll down. First, I am going to add my support email, and we can also change the public facing name to Budget App. It's basically the name that is shown to users whenever they use Google Sign-in and so on. Now, we need to add the SHA fingerprint. So we will go to our Android Studio and open the Android folder. And we will be opening this file, build Gradle, in a new window. The next thing to do is to open the terminal and run the command /gradlew signing report. For Mac, it's just gradlew signing report. You can see that it has started the daemon, which means that the command has run successfully. It is going to take a few minutes to initialize and configure. We need to wait for it to finish before we jump onto the next step. So as you can see, we have gotten our SHA over here in the terminal console. Now, what I am going to do is copy the SHA-1, the upper one, open the Firebase console, and paste it in the certificate fingerprint field. Make sure to save it. Next, we need to add the SHA-256, that is the lower one. So click on Add Fingerprint, copy the line, and paste it here. Make sure that you save it. Also, don't forget that all the letters need to be in uppercase. And it's done. Easy, right? Now, we are going to head back to the project overview. At this point, we have to add the iOS app. To begin with, let's click on Add App and select iOS. We need to give the app a bundle ID. So to do that, let us go to Android Studio and open the iOS folder. We are going to look for the project PBX folder here and search the word bundle in the search bar. And this way, we're gonna get the product bundle identifier. Let's copy this and paste it in the Apple bundle field. Next, I'm naming it iOS app, but it's optional. We won't be requiring the App Store ID, so we can leave it empty as of now, and then click on Register App. The next thing we will be doing is downloading this configuration file and saving it in the iOS runner folder. As mentioned earlier, getting the path right is very important. Now, simply click on Next. As you can see, I have already added the paths. So click on Next again, and on Continue. This will take you to the main page. Next in line is the web app, but before adding it, I will be setting up a few things in the main Dart file. Let's open the main Dart file now then. First things first, let's write widgets, flutter, binding, ensure initialized. Then we will be adding an if statement. If K is web is true, that means if we are running the app on the web, then it's gonna run set path URL strategy. And finally, await Firebase initialize app. As you can see, the file ain't imported. So let's import the Firebase core. To do that, we need to go to the beginning of the file and write import Firebase core and choose the Firebase core.dart. If the app is not running on the web, we have to write else await Firebase initialize app. Now in the above part, we need to tap into the options property and write Firebase options. And it's time to set the configurations. Let's head over to our Firebase web app console to do it. Click on the web app button and give it a name like web, for example. Notice that there's no need to set up hosting for the app. Now click on the Register App button to move to the next section. What we need to do here is just to copy the Firebase config details, starting from the API key till the end of this curly bracket. Paste these keys inside the Firebase options in Android Studio. Let's get back to our console. There is one more thing still left, and that is to add an OAuth ID. Without it, the Google sign-in will not work. So let's head over to console.cloud.google.com. Here you need to select the project from this navbar option. Since we are working on the budget app, we will choose that and click on Open. Now, let's click on APIs and Services under the Quick Access section and click on Credentials right here. You can find the web client credentials under the OAuth 2 Client ID section. So copy the OAuth ID, then open Android Studio, and from the web folder, open the indexed HTML file. I've already written the code here, so let's uncomment this line and then paste the credentials inside the content quotes. And finally, we're done with the web setup. I'm heading back to the Firebase console now in order to set up the authentication. So let's get started. Go to the authentication section in the left sidebar and click on the Get Started button. We need to enable the sign-in methods now. To do that, let's click on the sign-in method and then on email/password. The email and password service will be required, so we'll enable it and click on the Save button. We'll also use Google Sign-in, so let us click on Add New Provider, select Google, enable the service, and of course, make sure that you save it as well. Now that the authentications are enabled, here we will be able to see the users that are registered. Next, let's enable the Firestore database as well. In order to do it, we just have to click on the Firestore database. Next, we need to click on Create Database. And for now, I am choosing the test mode. Also, here you have to choose the appropriate server location and click on Enable. Let's go back to the studio now. As you know, we will be using hooks and Riverpod for the state management in this project. And I already have the packages imported in the pubspec.yaml file. If the package is not downloaded, just open the terminal and run flutter pubget, and it'll work just fine. Let's dive into the coding part now. I'm gonna wrap the My App with a widget called Provider Scope. As of the date of recording, the third version of Material Design has already been released. And if you want to use it, just uncomment this line. But since we are gonna be using our own design widgets, you wouldn't even notice much difference. Now, inside the Material app, we need to handle the responsiveness of the app. To do this, I have already created a responsive handler file, and in the home property, I'm gonna call the exact responsive handler. We don't need to use navigations here, as there are only 2 screens. I'm gonna open the responsive handler file now. Don't run your app just yet, as we haven't coded many parts. And if you run it without some more necessary codes, the app will crash. The responsive handler will switch between web and mobile versions of the app and also switch between the login screen and the dashboard screen, depending on whether the user is logged in or not. As you can see, we have used a hook consumer widget over here. As you might already know, we will be using hooks regularly throughout this module. Also, since we will be using Firebase authentications, we will need to check if a user is logged in or not. If the user is not logged in, it will show the login screen, and on the other hand, if the user is logged in, the responsive handler will show the budget app dashboard. First, let's figure out if the user is logged in or not. I'm gonna open the view model file now. As you know, this file will contain all the variables whose state needs to be updated throughout the app. So let's create a class named viewModel that extends change notifier. The package will automatically be imported. If not, then import the foundation package. Now we will create a variable called _off and then write Firebase off instance. The next step will be to create a bool variable called isSignedIn, whose initial value will be false. This variable will be used to see if a user is signed in or not. The value will change to true if the user is signed in. We're gonna comment here, check if signed in. And then we need to communicate with the Firebase server to check if a user is logged in or not. To do that, we will use a future void function called isLoggedIn. Obviously, it's going to be asynchronous. We're gonna write a wait now, and let's write off. And I'm gonna use the function of state changes, which is a stream of any authentication changes in our app. We need to listen to it, so I'll add .listen, and I'll change event to user $user here. So basically, it will accept the user variable that is provided by Firebase auth. Next, we need to use an if statement. That is, if the user equals no, then the user is not signed in. Therefore, the value of is signed in will be false. Otherwise, it'll be true. At the end, we need to notify all the listeners. It is pretty simple, right? Now it's time to create the provider variable. Firstly, I will call it viewModel. It's gonna equal change notifier provider dot autodispose. Let me add the angle brackets and put the viewModel class here. I'm also gonna add a pair of round brackets wherein I am going to write ref. Then I'm gonna return viewModel. Now we can use the variable to access the viewModel class from another class. Let's get back to the responsive handler file now. And inside the build method, we're gonna create a viewModel provider variable. Within this variable, we are going to write ref.watch. And here, we will put the viewModel provider which we are gonna watch. The file is not imported, so I'm gonna import the file now. And our next step will be to run the function isLoggedIn from the viewModel class to update the value of the variable isSignedIn depending on the login status of the user. So let me type viewModel provider isLoggedIn. Since it's a stream, whenever there is a change in the authentication status, the value of the isSignedIn variable will also change. Let me remove the unnecessary lines here. Instead, we want to check the value of the variable isSignedIn. If it's true, we will return the expense page. Now, there are two files for the expense page. One for the mobile version, and the other one is for the web version. So here we will call the layout builder. Instead of this word builder, let us write context and constraints. Let's open the brackets. If the constraints max width is greater than 600, then return the expense view web. Otherwise, we'll return expense view mobile. If isSignedIn is false, then we will return the login page. Once again, we return the layout builder with context and constraints. If the constraints of max width is greater than 600, then we will return login view web. So let me import it. And in the following else condition here, we will return login view mobile for the width smaller than 600. And that's it. We are done with the responsive handler. At this point, we will be focusing on the login mobile UI. So let us start with the login view mobile. Since we have two fields for both email and password, we need to create a controller for them. So let's create a text editing controller called email field. And instead of normal text editing controller, I will call the use text editing controller from the hooks package here. And then import the material package. Let me create another variable for the password field and write use text editing controller. It's time to create a view model provider variable now. And then we are gonna watch the view model variable for changes. We also need the device height. So let us call media query of context dot size dot height. Now let me return a safe area widget, and in the child property I will call a scaffold. In the body of the scaffold there is gonna be a single child scroll view. The reason why I used it is because whenever we want to fill a field with our data, the keyboard pops up and takes up some space. And if we don't have a scrolling widget, then all the widgets overflow from the screen. In the child property, I am going to call a column and I'm gonna set the cross-axis alignment to the center. In the children, I am going to start with a sized box and I want to set its height to device height divided by 5.5 to add some white space. I'm gonna call the image asset now and place a logo from the assets folder. In the fit property, I'm gonna write boxFit.contain and set the width to 210.0. Now let's run the app on the emulator and see what we have got. Let's wait a moment. And as you can see, we have our image here with some white spaces on top. The logo isn't in the center, but as soon as we use the row widget for the register and sign in buttons a bit later on, we will be able to fix it. Now let's create a sized box with a height of 30.0. Next, we are going to create another size box, but this time with a width of 350.0. And its child is going to have a text form field. You can definitely create a custom widget for the text form field and use it for both email and password fields, but I will repeat the code so that you get a better understanding of the widgets I'm choosing. Throughout the course, I might be repeating codes instead of having a function or a dedicated widget that can be reused, so that you take some more time to understand what's going on the screen, and it becomes crystal clear to you how exactly the widgets work. Since we're creating the email field now, we want to have a keyboard dedicated for typing email addresses. So let's write text input type dot email address. Then let's set the text alignment with text align to the center. In the controller, let's pass the email field, and in the decoration property, we're gonna pass input decoration. Next, let's tap into the enabled border property and write outline input border. Set the border radius to borderRadius.all and then write radius.circular with a value of 10.0. For the focused border property, I'll just copy and paste the lines from above. The next thing we will be doing is to add a prefix icon, which will have an icon widget where we'll use the email icon. I'm gonna set the color as black and give it a size of 30.0. In the hint text, I'm gonna write email, and then I am going to set the hint style property to Google Fonts.Open Sans. You can choose your own fonts too. And let's not forget to import the package. Now, I'm gonna create a sized box with a height of 20.0 and reload the app to see how it looks. It's gonna take a few seconds, so relax. And the changes have appeared. Let's add the password field now. I'm gonna start by adding a comment, followed by a sized box with a width of 350.0. In the child property, I'm gonna call a text form field and set the text align property to textalign.center. It's time to assign the password field to the controller. And I'd like to introduce you to a new property here called obscure text. It will have a value of either true or false. If it's false, then the text in the password field will be shown. Otherwise, the text will be replaced with asterisks. But first, we need to create a function that will toggle the value when clicked upon the icon button, which we will add later. Therefore, let's head over to the viewModel file. And let's create a variable called isObscure over here, whose initial value is true. Now let me scroll down a bit and create a function called toggleObscure, which will reverse the value of the isObscure variable whenever it's called. And the password will be visible or invisible depending on the value of the variable. Let's write notify listeners now, and then go back to the login page. I'm gonna call the isObscure variable from the viewModel file. Then, in the decoration property, I want to call the input decoration, and for enabled border, I am going to put outline input border. Next, let's set the border radius to border radius all. And it's gonna be circular and of 10.0. Now copy this content and paste it in the focused error border. Now in the prefix icon, we will add an icon button. When this button is pressed, toggle obscure function will be called, which will reverse the value of isObscure variable. In the onPressed function, I am going to call the toggle obscure function from the view model file. So whenever the button is pressed, the toggle function will change the value of the isObscure variable. Let me tap into the icon property and call icon. If the isObscure variable is true, then we'll use the visibility icon, meaning that when the user presses it, the text in the password field will not be visible. Else, we'll use the visibility off icon, stating to the user that when they press it, the text will be shown. The color of this button will be black, and the size will be 30.0. In the hint style property, I'm gonna write Google Fonts.OpenSans, and hint text will be password. Let's give it another size box with a height of 30.0 to have some more white space. Let me reload the app and see what we have got here. Let me type something in the password field. Oh, I think we need to change the focused error border to just focus border. Let me reload it again. Okay, so now when you write something in the password field, it will replace the text with asterisks. And when you click on the icon button, the obscure value will be reversed, and you will be able to see the password you write in the password field. This is such an amazing feature, right? Let's move on to making the register and the login buttons. First, I want to create a row that will have a main axis alignment of main axis alignment dot center. In the children property, I'm gonna call a size box with a height of 50.0 and a width of 150.0. It's gonna have a child called material button, which is going to have a text widget